Students, in the last video, actually I completed this lesson chemical reactions and equations. Okay, but some part of the lesson in between was left out. One of the students told me this. Actually, most of you must have told me. Most of you must have actually should have informed me. But only one student told me about this. Say to carry out endothermic and exothermic process. Okay, so today I will be explaining this to you. Now see, the apparatus required for this is two plastic bottles, measuring cylinder, thermometer, etc. Then chemicals you require is potassium nitrate, sodium hydroxide, water, etc. Okay, so these are the chemicals. So what all you require? You require two plastic bottles. See, you require two plastic bottles, measuring cylinder and thermometer. These are the apparatus you require. Then chemicals you require is potassium nitrate, sodium hydroxide and water. Now see, sodium hydroxide, okay, this being corrosive, you will have to handle it carefully, okay. So that is in presence of your teacher. Now procedure, take 100 ml water in each of the two plastic bottles. So what you are going to do? You are going to take 100 ml of water, okay, in two plastic bottles. Then plastic being insulator of heat, the dissipation of heat can be prevented. So actually this plastic, it is insulator, yes, of heat. The dissipation of heat can be prevented, means the transfer of heat from inside to outside and from outside to inside can be prevented. Note the temperature of water in the bottles. Okay, so you're going to note down the temperature. Now put 5 grams of potassium nitrate, that is KNO3, in the bottle and shake well. Okay, now what you're going to do, see, you're first of all going to take two plastic bottles. Okay, you're going to take two plastic bottles. Then you're going to take 100 ml of water, okay, in each of the two bottles. Then what you're going to do, you're going to first see the temperature of the water. Then you're going to add potassium nitrate, 5 grams of potassium nitrate in the bottle, and you're going to shake it. Now note the temperature of the solution formed. Okay, so the solution which has been formed now, you're going to note the temperature of that. So you know the temperature, initial temperature, that is before adding potassium nitrate. Okay, you have noted down the temperature. Now you are going to add potassium nitrate, you are going to dissolve it, and then you are going to see the temperature of the solution. Then in the, you have taken two bottles, isn't it? So in the other bottle, what you are going to do is, you are going to add 5 grams, okay, of sodium hydroxide, same amount of sodium hydroxide in the other bottle. Then again you are going to shake the bottle, okay, and you are going to note down the temperature. See, in the first bottle, the process of dissolution of potassium nitrate took place, while in the second bottle, the process of dissolution of sodium hydroxide took place. As per your observation, which one is exothermic process and which is an endothermic process? Okay. Now, see, you have noted down the temperature when you added, that is before adding potassium nitrate and sodium hydroxide. So the temperature of water is going to be same in both the that is in both the beakers, okay, in both the bottles, sorry, in both the plastic bottles. Then what you have done, in first bottle you have added potassium nitrate and you have that is shaken well, so it dissolves in that. Okay, so then again you noted down the temperature. Then in the second bottle you added what? Sodium hydroxide. Okay, and you saw the temperature of the second bottle also. That is the temperature of the solution of second bottle also. Now see what you have observed. Now see what happens is, in first case, okay, that is when you add potassium nitrate, okay, when you that is shake it, and when you touch the bottle, you will find that the temperature has cooled down, and you have seen the temperature by the thermometer also, isn't it? Now the temperature would have decreased. Okay, so this means, okay, the temperature from that is the temperature from outside has been used up, okay, for the reaction to take place, for the dissolution of potassium nitrate, and the temperature has decreased of the solution of potassium nitrate. Okay, you think the solution, the water, okay, before you assume it that the temperature of the water is somewhere around 30 degrees Celsius. Okay, now when you add potassium nitrate, the temperature would have decreased. It's less than 30 degrees, might be 20, 25. Okay, so this shows that endothermic reaction has taken place. But you know, in case of dissolution of sodium hydroxide, what has happened is the temperature has been released. Okay, now that is why that process is exothermic reaction. Now, during the process of dissolution of potassium nitrate in water, heat from the surrounding is absorbed. Therefore, the temperature of the resulting solution is less. That's what I told you, isn't it? That the process of dissolution of potassium nitrate in water. Okay. So, heat from the surrounding has been observed, and therefore what has happened? The temperature of the resulting solution is less. Okay, it has decreased. So this process in which heat is absorbed from the outside, we call it as endothermic process. But in the case of sodium hydroxide, when the solid sodium hydroxide is dissolved in water, heat is given out. Okay, so this also I told you, in the case of dissolution of sodium hydroxide, heat has been released out. So therefore the temperature increases. So the process in which heat is given out are called exothermic process. Now this is very important definition. See, and you should be able to give the examples also if asked in the exam. Okay, definition of exothermic and endothermic reaction with examples. So you should be able to give these examples. Now, so in case of endothermic, potassium dissolution of potassium nitrate in water. So what has happened? The process in which the heat is absorbed from the outside is called endothermic reaction. And the solid, okay, when, see, in case of dissolution of sodium hydroxide, what has happened? Temperature has been, heat has been given out. That means what? The temperature has increased. So the processes in which heat is given out is called as exothermic process. So what is endothermic? The process in which heat is absorbed from the outside, and in this case the process in which heat is given out. Okay, so that is exothermic processes. Endothermic and exothermic reactions. Okay, now see, you have understood what is endothermic and exothermic reactions. There is an exchange of heat in chemical reactions as well. Accordingly, some chemical reactions are exothermic while some other are endothermic. During exothermic chemical reaction, heat is given away when reactants are transformed into products. While during endothermic chemical reactions, heat is either absorbed from the surrounding or has to be supplied continuously from outside. For example, see, I will explain this with the help of example. See, many chemical reactions are taking place. Now, during the chemical reactions, what happens is, in some cases, that is during chemical reactions, okay, you will have to supply heat continuously from outside, or else it uses heat from the atmosphere. Now, this type of reaction we call it as endothermic reaction. But in some cases, what happens is, the reactants, okay, combine to form products with the release of heat energy. So this type of reactions we call it as exothermic reactions. Now see, in this case, calcium carbonate CaCO3 plus heat. Okay, so in this reaction, what is happening? This is the reactant. Like, see, now see, this is the reactant, calcium carbonate CaCO3 plus what is happening? It is using the heat. We have to supply heat to that during reaction. During the formation of this product, calcium oxide and carbon dioxide. Now, because we are supplying heat for this process during the reaction, that is why we call this type of reaction as endothermic reaction. Now, in the second case, see, the calcium oxide, okay, plus water, okay, when you add water to calcium oxide, that time calcium hydroxide is formed, CaOH twice. But during the formation of this product, calcium hydroxide, heat is also liberated. So this type of reaction we call it as exothermic reaction. Students, let us try to understand exothermic and endothermic reaction with the help of this small video clip, with the help of this activity shown over here.
Up and ready to go. And one of the 20 degrees C room temperature. And I'm going to load. Hi, I've got a couple of demos loaded up and ready to go. And one of these is going to go ahead and give off heat, and the other one's going to have heat taken in. So I've got a beaker of water at room temperature. The red display shows that it's near 20 degrees C room temperature. And I'm going to lower the temperature, and I'm not going to do so electronically like with a freezer, and I'm not going to do it with ice. I'm going to dissolve a solid, which is actually going to promote an endothermic process. The solid is called ammonium nitrate, and I have the formula on the board, and I'll point that out to you in just a moment. What's going to happen is water molecules will surround this, and the reaction actually sucks in energy. So we're going to see a nice little temperature decrease here. So as I tap this in and it's stirring,
see, the temperature is slowly falling down, it's reducing.
On a good day, it'll drop down to about 0 degrees C. So it looks like we've got 7, and it's continuing to drop. The driving force for this reaction is the dissolving. The ammonium and nitrate ions are being surrounded by water, and it's going to a state of more disorder, as we say, and it's making the reaction happen. But in the process, think of it as like an energy vortex. Heat from the outside, heat from the water are sucked in to make the reaction proceed. Oh, and very good. It keeps dropping at 5. There aren't too many of these reactions, so this is rather novel. I also give it the nickname of the cold pack reaction, because these first aid cold packs, these little plastic bags with an inside bag, are available at pharmacies, and what will happen is if somebody bumps themselves like in the playground, somebody might come running over with one of these cold packs. What they do is snap it, and it's mixing water on the inside with the ammonium nitrate, and it's spontaneously going cold, as demonstrated. Another little process loaded up here is just a simple combustion. I have some methanol, which is a 1-carbon alcohol, and I'm going to spray some on the counter and just go ahead and light it on fire. And flames are given off, a sign that we have heat, and I'll give personal testimony. It's warm. We have yellow, orange, blue flames here. it's combusting, heat's given off.
See,
That
heat
energy
is given
that's given off as
away
heat
here.
came from
That is
chemical
why it is
energy
an
to begin with.
exothermic
Bonds are
reaction.
being broken, which costs energy, but then new bonds are being made and energy is being released. Let me go ahead and show you the processes up here on the board. The left side is the first reaction, and that is the cold pack reaction. The ammonium nitrate is a solid, and it's mixed with water and becomes ammonium nitrate aqueous. So these are two separate items.
Anything mixed with
NH4
water,
plus
it
is
becomes
floating around,
aqueous.
NO3 minus is floating around in the water. And at the beginning here, call it a baseline or the before enthalpy or heat, this is done at constant pressure, is around here. And what's happening is it's sucking heat in from the environment, from the water and the air. The analogy might be something like your checking account, where checking account starts here, then it's payday and a deposit is made. Ooh, that's nice. We increase the heat of the system, or the enthalpy, the heat at constant pressure. The time axis is simply just showing before and after. I have an arrow here going heat is taken in, so the energy of the system rises. Endothermic, or entering heat, heat enters the system. On the right side is that combustion of the alcohol. CH3OH is methanol. It burns in oxygen in the environment, and then we produce carbon dioxide and water. We start off with some high energy bonds, and then we end up with basically waste products, carbon dioxide and water. When you exhale, carbon dioxide and water come out. You extinguish candles with this. We use these in fire extinguishers, very low energy molecules. We start off high, we end down low. There's a little bit of an activation energy at the beginning, that hump that we have to get down over. Heat is given off in this process. Exiting heat, exothermic. What I'd like you to do is think about the delta H values for these two. One is going to be positive, one is going to be negative, which before and after case, and our exothermic process starts off high, goes down low, so there's a loss of system energy or system heat. So that's a nice little couple of
See, heat is, okay, in case of endothermic, okay, heat is positive and heat is negative. You can see over here. Yes. That is, in case of endothermic, heat is positive. In the case of exothermic, heat is negative. Okay. So, I have explained to you the missed part of the lesson also. Okay. Yes. So, I have completed this lesson. Complete the exercise. Okay. And send it to me.